Let's now discuss about adjusted R square. In the last two videos, we have discussed about linear regression as well as R square, right? Now you can see adjusted R square versus adjusted R square. So this is again one of the most important interview question, when to use adjusted R square and how is it different from R square. Do not skip any part of the video so that you can completely get this concept. So this is the formula for adjusted R square, right? 1 minus R square into n minus 1 divided by n minus k minus 1. So what is this R square? This is what already we have discussed, right? And n is nothing but number of records, number of observations, number of rows. K is nothing but the number of independent variables. Very simple, right? Memorize the formula. Definitely it is important because you are expected to answer that too, right? If you have missed out R square or linear regression video before, I'm giving the links in the description box. You can just click on that. Please go through that and come back. If you know those two concepts already, please proceed with this adjusted R square. So I'm using the same data set what I have used for R square. So you can see I have imported NumPy pandas linear regression as well as R square. And the problem statement is to predict the price based upon the area. So area is the independent variable and price is the dependent variable. So I have created my data set, right? So this is how it is looking like. As I told you, dependent variable is price. So it is taken in y-axis. Independent variable is area. So it is taken in x-axis. So I have instantiated linear regression model and fitting it with x and y. So let me try to get the intercept as well as slope. So if you all could recollect what we have discussed about it, y is equal to mx plus c, right? So now you can see here the intercept value we got it like 109.86. We have already discussed this, right? Just I'm doing a small revision on it, right? And then slope also we have printed 0.16. So what am I trying to find out? Price. So price is equal to m. M is 0.16447368. 7368, right? And then into x. X is nothing but area, right? Plus c. C is basically this 109.868. So let me write it short, right? So this is what we got it as an equation. Now, in case whenever I have the value of area, I would be able to find out the price, right? So that's the concept already we have discussed. So let us now try to understand about adjusted R square. So if you remember, this is the formula, right? Formula of R square. Now, this is the formula of adjusted R square, right? So let's now try to do this. So I'm just showing you with the formula how this actually works. Let us also try to calculate it mathematically. So 1 minus R square into n minus 1 divided by n minus k minus 1, right? So R square value is already computed, if you remember, right? Already we have got this, right? Model dot score x comma y. How we have arrived at this result, I have explained in R square video, which I'm going to give in the description box. Okay, so now here I will substitute and show you so that you can understand it better, right? So 1 minus R square. So basically what am I trying to do now? 1 minus R square, right? So 1 minus R square is nothing but this is the one. So 0.9868 to 6842, right? 105. Okay, whatever it is, right? Into n minus 1. N is nothing but number of records. How many records are there in this data set? Exactly, 5, right? So this would be like a 5 minus 1 divided by n minus k minus 1. So n is nothing but 5. K is number of independent variables. Okay, independent variables. N is number of records, right? So number of independent variables means we have only area here. So that is only 1 minus 1. So what are we trying to do here? This will turn into 4. 5 minus 1, 4. 4 minus 1, 3. So whatever we get it over here into 4 by 3. So let me show you that. So you can see here 1 minus, this is R square value. This is what we are getting into n minus 1 divided by n minus p minus 1 or n minus 1 divided by n minus k minus 1. Already I have showed it like 4 by 3. I'm substituting this and I got it. Still one part is missing, right? 1 minus this part. So 1 minus whatever answer we got here, substitute 0.982456. You can see that same thing we have got it over here, 0.94. Right? This is adjusted R square, right? So now the question could be like, right? Why should we do adjusted R square? Because almost we are getting the result close to R square. Why is adjusted R square required? So adjusted R square is basically the modified version of R square only, but it will try to adjust the number of predictors in a regression model. So what do I mean by that? Number of predictors are nothing but independent variables. So let me make it very clear. See, I have one independent variable, right? One independent variable. I'm computing R square. Then I have two independent variables. Now you can see that R square value will rise. Three independent variables. Further, you can see that R square value will rise. So whenever we increase the number of independent variables, number of columns, right? Independent attributes, R square value will increase irrespective of the significance of the column. For example, I have the data like area of house, age of house, age of buyer. Based upon that, I'm trying to predict the price of the house. We know that area is important. So area is significant feature. Age of house is also significant feature. But we know that age of buyer is not really significant, right? But when you try to calculate with the help of R square, just because another new column is added, right, R square value will increase irrespective of the significance of the attribute. But in adjusted R square, it is not like that. In case, if the added attribute is not significant, the value will not actually increases. So how you should answer in the interview? Why should we use adjusted R square? It penalizes for adding irrelevant predictors, irrelevant independent variable. With R square, the value will always increase or it may stay the same whenever a new column is added, but adjusted R square value will increase only if the new column is really significant, right? And also it helps to avoid overfitting also. And another one, adjusted R square always give a comparison between the models. Say I'm making a model with linear regression, decision tree regression, random forest regression, with multiple regression models, right? I want to know which model is really the best model, right? So there again, we can go ahead with the adjusted R square. I hope the concept is clear to everyone, right? So this is very important question. You can look into the video. If you really like the video, if you really get the concept, just hit like, subscribe, and also please share it with your friends. So if you are looking forward for any other additional concepts, please write it in the comments so that I can make a video out of it. Thank you so much.